Okay friends, today we have got a problem out there, and that is based on combinatorics. And as you know that some of the combinatorial identities, like this particular example that you can see on this blackboard. Okay, so this is a combinatorial identity which is true for n to be natural number. Okay, and the combinatorial identity is 1 into nc1 plus 2 into nc2 plus 3 into nc3, and this continues up to n into ncn, and the result is going to be n into 2 to the power n minus 1. So the point is that this combinatorial identity can be easily proved using the concept of binomial theorem. Okay, but in this particular discussion we are not going to that prove based on binomial theorem, because usually that can be found out in any textbook or any literature of mathematics. So today what we need to do is that we need to prove this combinatorial identity using a logical conclusion using combinatorics. Okay, so we need to prove this logically using the concept of combinatorics. Now for this we are taking a problem, and the problem states that find the number of all possible committees that can be made with a chairman from n persons. Okay, so we have got total n persons out there, and we need to create all possible committees of different number of members, but there should be a chairman in that particular committee to lead them. So for solving this particular question, we will try to do it from two different angles, and in the process we'll try to prove this combinatorial identity. Like you see that in the LHS we are having a different approach of solving this question. That is, the first one is giving us the number of committee of one member. Okay, so what we are doing is that out of n member I am choosing one member, out of n persons I am choosing one person, and then after choosing that one person I will choose a chairman, and that can be done only in one way. Okay, so this will be the committee with one member. Or that is plus, we can have a committee of two member. So this is the number of committee with two members, because for that what we are doing, out of n person we are choosing any two person. That can be done in nc two ways, and after choosing the two persons we are choosing a chairman in two way, right? Because out of that two person we can choose any one to be the chairman, so that can be done in two ways. So this thing will become the number of committees with two members. Similarly, the next one will be the number of committees with three members. Okay, for that what we are doing, out of n persons we are first choosing any three persons. That can be done in nc three ways, and after choosing that three persons to be the three members, we need to choose a chairman. That can be done in three ways. Okay, so in this way we can see that these are representing number of committees with one member. This is number of committees with two members. This is number of committees with three members. In this way, finally we are having number of committees with n members. Okay, so you can see that these are all possible committee formation. A committee can have one member, two member, three member, or n member. So these are all possible committee formation. So we can say that the answer of this question is the LHS. Okay, but also we can think from another angle to solve this particular question. That is, first we can choose a chairman. Okay, so that chairman, suppose P1, P2, P3, P4 up to Pn. Okay, these are the n persons out there. So what we can do is that first we can choose a chairman. Okay, so that can be done in n ways. Okay, out of n persons we need to choose a chairman, because a committee has to have a chairman. So we can choose that chairman in n ways, and after choosing that chairman we will be, suppose let us assume that P4 is that particular person is chairman, is already selected. So we've already selected P4. Now how many persons are left out? If P4 is gone, then n minus 1 persons are left out. Now for those n minus 1 persons, we can see that for every person we have got two possibilities. Either we will be selecting that person in the committee, or will not be selecting the person in the committee. Similarly for P2, either will select that person in the committee or will not select in that committee. Similarly for P3, either will select in the committee or will not select in the committee. And finally in this way for Pn, either will select in the committee or will not select in the committee. So basically what is happening, we can see that after selecting a chairman in n ways, then for the rest of the person there are two ways, that is either select or reject. Okay, so for rest of the n-1 persons there are two ways. So we will continuously multiply the two ways for every other person. Okay, so n is the number of way we have chosen a chairman, and for rest of the person we have got two ways, either select or reject in that particular committee. So that will give us so here n-1 terms are there because n-1 persons will be there, so that will give us the answer to be n into 2 to the power n-1, which is the answer we are seeing on the RHS, n into 2 to the power n-1. So we can see that from here, from using this logical conclusion, we have proven this combinatorial identity, which could have been proven using binomial theorem after a little bit of hard work. Okay, so simple logical idea have proven this combinatorial identity in a very innovative manner. So thank you for watching this video. This is my contact info. You can contact me if you're having any doubt, and in the meantime please subscribe on YouTube and like us on Facebook for the video updates. And for subscribing, you can see there's a subscribe button out there just below your video, and you can just click that subscribe button if you think that this kind of video is worthy of watching. And thank you very much. Bye bye.